Hello everyone, I hope everyone is doing great. Welcome back to my channel Build with Jaswinder. As part of this video series, today we will be building the logic for this Leetcode problem 1 to 4, which is binary tree maximum paths. In this, you are given a binary tree and you have to find the maximum path. The path is a path where each node can only appear in the sequence at most once. So let's say this is not a valid path because here 5 is appearing two times if you check. And you also note that the path does not need to pass through the root. So this is also a valid path if it's giving you the maximum path sum. Okay. So basically you just have to find such path which gives you the maximum sum. Okay. So if you notice in this test case, what should be the maximum path sum? If you go all the way from 1 to 10 to 5 to 3, it's a valid path as each node is appearing just once, right? And the maximum and the path sum is 1 plus 10 plus 5 plus 3, which is 90. And if you check, there is no other path which is passing through the root or which is not passing through the root, and it's giving us sum greater than 19. So for this particular test case, the output should be 90. Now how to solve this? If you notice in my previous videos, there are two ways to solve these kind of problems, either using BFS or using DFS. I'll be using DFS here, which is more intuitive. So in DFS, generally you have to traverse the tree. There are different methods. You could traverse it pre-order, post-order, or in order. Here I'll be using the post-order traversal where I'll be visiting the children nodes first before visiting the parent. Okay. So how should I approach this problem? So we are designing the solution using recursion, you don't have to go deep inside the recursion initially, right? If you have watched my previous videos, first you have to develop the core logic, right? Without thinking too deep or without going too deep into in the recursion, and then you have to come up with the base cases. So these are the two steps to solve a problem using recursion. So let's say what happens if I'm standing here at this particular node. What will be the maximum path? So if I'm at 3 and I want to include 3 in my maximum path, either this 3 can get added to the left sum, right? So the left sum is 0 because there is no 3 here, right? Similarly, the right sum is 0. Let me just write it down so that it's easy for you to understand. So for this particular node, the left sum is 0, the right sum is 0, and I'll have one variable here, max path sum. Initially, it's negative. Okay. So when I'm standing at this particular node 3, what will be the maximum path sum including this 3? Either I could take something from my left sum if it's positive, or and I could take something from my right sum if it's positive. Here it's 0, it's 0, so 3 plus 0 plus 0 is 3, so which is greater than max path sum, right? So we'll be updating this max path sum for each node, right? When I'm at a particular node, let's say when I'm at this node, I'll be checking what could be the maximum path sum including this 5. If it's greater than this value here, I'll be just updating it. Okay. Now, here you noticed the left sum got updated to the sum max path sum got updated to 3. Okay. Now, let's say I'm at this node 2. For this node also, the left sum would be 0 as there is no node in the left sum in the left subtree. Similarly, the right sum would be 0 as there is no node in the right subtree. Now, when I'm standing at this node, what will be the maximum path sum including this node 2? So either this 2 can take something from the left sum or this could take something from the right sum, but all it could take is 0. So the total sum would be 0. Is it greater than this 2? This 3 here? No, it isn't. So we'll not update this. So it remains 3. Now see, what should we return from here? And what should we return from here? So we need to return some value to our parent so that we help our parent to find the maximum path sum, right? So you have to think here that when I'm standing at this particular node, what should I return to my parent? There are two possibilities here. Either I could return a path which goes from 2 to the left child, or we could return the path which goes from the root to the right child. We have to return either of these two. We can't return a path which is this one, because if we return this path to our root node, then it might calculate this path as a valid path, which is not a valid path, right? So we have to return either of these two. Okay. So let me just write down the same values for this node here. So when I'm at this node here, 5, the left sum would be 3, because from this node it will return me either 3 plus 0 or 3 plus right sum, which is also 0. So it will return the max of these two values, which will be 3. Similarly, the right sum for this particular node would be 2 plus left sum or 2 plus 0, whichever, 2 plus right sum, which is maximum, whichever is maximum. So it will return me 2. Now I need to check what will be the maximum path sum which is passing through the 5. So this 5 can take something from the left sum, right? And it can also take something from the right sum if it's positive. So 5 plus 3 is 8. 5 plus 3 plus 2 is 10. Is this 10 the sum which is passing through this root node with, and which is this is greater than the max path sum we already calculated? Yes, it is. So we'll just update this to 10. Right. Now we need to return something to our parent. What should we return? That's the question. So what do you think we should return here? So let me write down the same values for L sum and right sum here. So either, if you notice, either I could return this 5 when it's added to the left sum, or I could return this 5 when it's added to the right. So I have to return the max of these two, so that when this node calculates the max path sum, it can find the max path sum, right? The catch here is I can't return this path, because when I'm returning this path, then this will not be a valid path, as this node will be part will appear in the sequence two times. So what will be the right sum here in this case? So it will be the max of 5 plus 3 or 5 plus 2. So the max is 5 plus 3, 8. And what will be the left sum here? So left sum will be coming from this node, and I'll just quickly calculate the values 0, 0. Here I'll return 1 plus max of left sum or right sum, which is 0. So I'll just return 1 here. So left sum will be 1. Now what happens is I'll be doing the same calculation. So what will be the maximum path sum passing through this 10? Okay. Either this 10 can take something from the left sum, and it can also take something from the right sum. So 10 plus 1 is 11 plus 8 is 19, which is greater than this 10. So I'll just update this 10 to 90. And what should I return further? There is no node on top of it, but if there was a node, then what should I return? Tell me. So this 10, to return to the parent, either this 10 can add it to the left path or the right path, whichever is the maximum. So in this case, 10 plus 1 is 11, 10 plus 8 is 18. So I'll be returning 18, which is this path to my parent. Okay. So I'll be just writing the same pseudocode here, so you guys find it easy to write it on the Leetcode. So let's say I have a max path sum variable. Initially this will be negative value, and I have one function which is int max path to leaf. So this function, what it does is it calculates the max path from the given node all the way to the leaf. Okay. So there, if you know, there will be a base case here. I will write the base case later, and then there will be a core logic here. Okay. So let's assume I already have the answer for my left children and my right children. So max path to leave. So let's say I have L sum, which is the maximum sum from my left children. Okay. If you remember, it will be the max value of, there are two options, right? Either I could take something from the left sum or I could ignore it if it's negative. So I'll just handle it using this max zero. So max path to leaf. I'll just pass the root dot left value. Okay. So if you know what I'm trying to do here is I'm asking to get the max path from my left children, and then I'm calculating the left sum. How? Either I could take something from this one or I could just ignore it if it's negative. Okay. Similarly, I do the same for my right subtree also. Either I could take something or I could ignore it if it's negative. So I will just call max path to leave and pass my right children to this function call. Now I need to update my max path sum. What will be the max path sum? It would be the max value of max path sum, comma, root dot val. So now what will be the maximum path sum including this root val? Either this root val can take something from the left sum, right? And it could take something from the right sum depending on if this is 0 or it's positive here. So if this is positive, it right sum takes that value. Otherwise, it just ignores with this 0. Okay. So now in the end, what do we need to return? We need to return the max path to leaf. So now, including this root value, what would be the maximum path to the leaf? So either that leaf will be in the left children, okay, or that leaf could be in the right children. So whichever is the maximum, we just return it. So that's all. You don't have to think too much deep inside the recursion. This is your core logic. Now let's write the base case here. So what will be the base case here? If you notice in my function call here, there could be a case when this root is null. So it means that will be part of our base case. So what happens if our root is null? What will be the maximum path to leave if our tree is empty? It's easy. It will be 0, right? If the tree is empty, the max path would be 0. So we just return the 0. So that will be the base case. And if you notice, what will be the time complexity of the solution? We are just visiting each node at max once, right? So the time complexity would be O of n, and the space complexity would be O of h, where h is the height of the tree in the stack trace, right? So it's the, we can argue that it will be, in the worst case, it will be O of n if our tree is skew, right? Now, I'll just show you the same problem on the Leetcode website, okay? Sorry for the screen rotation, but I'll just show you the same problem on the Leetcode website. So here I'll write the base case, but before that, if you notice, I have to declare one variable int max path sum. Okay, initially its value will be the min value, and then I have to define that function max path sum to leaf. I have to pass this value root, and in the end I'll just return the max path sum. Now I'll write the implementation for this max path sum to leaf function. To leaf, I'll just accept the parameter root. There will be a, if you notice, remember the base case was if root is null, then the max path sum to leaf is 0. Okay. Now I'll calculate the left sum. The left sum would be the max of 0. Either I don't consider this left sum or I consider this left sum if it's positive. Okay. Similarly, I'll do the same for the right sum. But in the right sum, I need to pass the right here and I'll just make it as right sum. So now I'll need to update my max path sum. If the current sum, which is passing from the current node, is greater than the max path sum, then I'll just update my max path sum. Now I need to return the max path sum from this current node. Either this node can get added to the left sum or it could get added to the right sum to return the answer to my parent. I can't add both of them, otherwise that path will not be a valid path. So I'll just try to submit it and let's see what happens. So the basic test case is passed. Yeah, and it got accepted. If you see that it beats 100% of the solution, it's because it's ON solution. I hope you guys understood the problem and the solution. And if you do, please like this video and subscribe to my YouTube channel. I'll be posting more such videos in future. See you guys in the next video.